Alright, now we're moving on to section 11.1 and 11.2, so we're going to be continuing with trig limits, but we're going to be using the limits to help us find trig derivatives, or specifically we're actually just going to be looking at the derivatives, but remember that the derivatives come from the limit definition of the derivative. Anyway, moving on. So, first, the derivative of sine of x. So we saw this in one of our earlier warm-ups in this unit. It was warm-up 2. We used the limit definition of the derivative to show that the derivative of sine of x with respect to x is cosine of x. You could use the same process to learn that the derivative of cosine of x with respect to x is negative sine of x. So these two you want to, again, memorize, I would recommend. Obviously you can figure them out using the limit definition of a derivative, but it's easier if you don't have to do that each time. And if you know the derivative of sine of x, and you know the derivative of cosine of x, and you know trig identities, you can come up with the derivative of any other trig function. Before we do that, I want you to find dy dx when y is 2 sine of x plus 3 cosine of x. Pause the video, unpause when you're ready to check your work. Yes, it was that simple. 2 cosine of x minus 3 sine of x is our answer. Okay. We also want to understand that the chain rule still applies to trig derivatives. So d sine u dx, where u is a function with respect to x, becomes the cosine of u times the u dx. And then the same thing with cosine of u. If I want to take the derivative of cosine of u with respect to x, and u is a function with respect to x, that's negative sine of u times du dx. So if I have x cosine of 3x. Let's take the derivative. Well, we have to use the product rule and the chain rule. So the derivative of x is 1. So we'll have 1 times the cosine of 3x plus x times the derivative of the cosine of 3x. Well, what's the derivative of the cosine of u? That's going to be negative sine of 3x times the derivative of u with respect to x. So the derivative of 3x is 3. So we can simplify this slightly, and we can say cosine of 3x minus 3x sine of 3x. Good stuff. Okay, so now I want you to try y equals the square root of sine of 6t, find y prime. Pause the video, unpause when you're ready to check your work. Okay, so here we have to use the chain rule, and then the chain rule again. So first the derivative of the square root of sine of 6t is going to be 1/2 sine of 6t to the negative 1/2 times the derivative of the sine of 6t, which is the cosine of 6t, times the derivative of 6t, which is 6. Now I can simplify this. 6 times 1/2 gives me 3. Cosine of 6t stays in the numerator. Sine of 6t to the negative 1/2 goes to the denominator. So we should get 3 cosine 6t over the square root of the sine of 6t. That was fun. I want you to evaluate y equals sine squared of x. I'm sorry, evaluate's the wrong term. I want you to find the first derivative of y equals sine squared of x. Pause the video, unpause when you're ready to check your work. Okay, so we should end up with, we have to use our power rule and our chain rule. Bring down the 2 times the sine of x to the first times the derivative of the sine of x, which is the cosine of x. So y prime is 2 sine of x cosine of x. Or recognize that's our double angle identity. Y prime is sine of 2x. Either of those would be correct. Alright, next thing what I want you to do is I want you to use your knowledge of the derivative of the sine of x and the cosine of x, your derivative tools, and your trig identities to come up with the derivative of tangent of x and the derivative of secant of x. So pause the video, try to find those derivatives, unpause when you're ready to check your work. My hint is, as I mentioned, you want to work in terms of sine and cosine. So use your identities to turn both of these in terms of just sines and or cosines. Alright, so the derivative of tangent of x is secant squared of x. How do we come up with that if you weren't sure? Well, if I say y equals tangent of x, I can rewrite that as sine of x over cosine of x using my quotient identity. Now when I take the derivative, I use the quotient rule. So bottom times the derivative of the top, the derivative of sine of x is cosine of x, minus the top times the derivative of the bottom over the bottom squared. Now if I simplify this, I end up with cosine squared plus sine squared in the numerator. That's my Pythagorean identity, that is 1, so I get 1 over cosine squared of x. That simplifies to secant squared of x. For the derivative of secant of x, I should get secant of x times tangent of x. There's a lot of different ways to write this. This is just usually how it's seen. So how do I come up with that? Well, y equals the secant of x, which is the same thing as cosine of x quantity to the negative first, because it's 1 over cosine of x. Remember, this is not the arc cosine. This is different. So now I can use my general power rule and my chain rule to take the derivative. So y prime is going to be negative 1 times cosine of x to the negative 2 times the derivative of the inside, which is negative sine of x. So the negatives cancel and it becomes positive sine of x over cosine squared of x. But this I can rewrite as 1 over cosine of x times sine of x over cosine of x. 1 over cosine of x is secant of x. Sine of x over cosine of x is tangent of x. So we want to know these derivatives. The chain rule, again, also applies to these. d dx of tangent of u is secant squared of u times du dx. d dx secant of u is secant u tangent u times du dx. So I want you to use that and find y prime when you have y equals tangent of the quantity x squared. Pause the video, unpause when you're ready to check your work. There's really not a ton of work. We should end up with secant squared of x squared times the quantity 2x. Okay, so some other trig derivatives. We're not going to go through the proofs of these. You can do that on your own if you want. It's the same idea as what we did for tangent and secant to find the derivative of cosecant and cotangent. So the derivative of cosecant is going to be negative cosecant of x times cotangent of x. I'm sure you can picture how that happens based on how we got the derivative of secant of x to be secant of x tangent of x. And again, the chain rule applies, so if we have d dx of cosecant of u, it's negative cosecant of u cotangent of u times du dx. d dx of cotangent of x is negative cosecant squared of x. Again, I'm sure you can picture how that's going to happen using your trig identities and how we came up with the derivative of tangent of x. d dx of cotangent of u is negative cosecant squared of u times du dx. So you either need to memorize all these trig derivatives or be able to come up with them on your own. You will not be given them on a test or a quiz. In fact, on some tests and or quizzes, you might have to just fill in blank trig derivatives. We'll talk more about that in class, though. But you should know them. Alright, so last example, I want you to find f prime of theta given given f of theta equals 5 theta times secant of theta plus theta times tangent of theta. Pause the video, unpause when you're ready to check your work. Okay, so we should end up with f prime of theta is 5 times secant of theta plus 5 theta secant theta tangent theta plus tangent theta plus theta secant squared theta. We get that by doing the product rule on the first term and the product rule on the second term. It's really tempting to try and simplify this somehow to try to factor, and to be honest, it might simplify, but it's going to be more work than what I'm asking you to do right now. If I do want you to get something into factored form, I would tell you. Otherwise, just combine like terms if possible, or leave it if you don't see any obvious like terms. Okay, so we want to make sure that we know our trig derivatives. Really make sure you know sine and cosine, because if you know sine and cosine, you can come up with all the other trig derivatives if you forget them.